We want to find an expression for f of x and say this domain. Okay, so f of x, or f as a function, takes a real number x. So that's where we're starting off. Perform the following three steps in order given. Divide by 4. So we got f of x is equal to x divided by 4. So you take whatever's in the previous transformation and you divide by 4. Then we're going to add 3. So that's going to be x over 4 plus 3. And then we'll multiply by 2. So we got f of x is equal to 2 times x over 4 plus 3. So we're multiplying what's in our previous transformation by 2. Now if I multiply the 2 through, this is a distributive property. So we're going to have f of x is equal to 2 times x over 4, and we'll have 2 times 3. Now 2 and 4 are both divisible by 2. 4 divided by 2 is 2, 2 divided by 2 is 1. So then we got f of x is equal to x over 2 plus 2 times 3 is 6. It's hard to say exactly how the answer will be written, because I haven't looked at the answer prior to working this problem. But if we left it in this form, typically you put the number out in front. And with a 2 down here, that's the same as having a 1 here, so that's 1/2 x plus 6. This is actually called slope-intercept form. Some very rare books might actually merge that into a single fraction. Now if I did merge it into a single fraction, this would be 6 times 2 plus x over 2. This is a mixed number form, even though it has x's involved. So we take the number to the side times the denominator. Then we add the numerator, and your denominator stays as is. So we got f of x equal to 6 times 2 is 12 plus x over 2. And I'll rearrange it so the x is first. And we'd have x plus 12 over 2. Now this answer that I just circled here and the one I previously circled are both correct. Just different ways you can write it. Some books imply that simplified form means a single fraction, and then some, if you're talking about linear, want it always to be written in slope-intercept form. Okay, now our domain. Our domain is all real numbers except for ones that cause the denominator to equal 0. Well, neither one of these forms has x in the denominator, so we don't need to worry about that. Or ones that cause a negative number inside of a radical with an even index. And we don't have a radical with an even index, so by default our domain is all real numbers, written as negative infinity to positive infinity.